Here we're looking at whether or not f is continuous at x equals 3. So, in order to figure out if f is continuous at x equals 3, we need to use the definition of continuity. The first part of the definition of continuity says that f of c, or in this case f of 3, has to exist. So f of 3 is equal to the square root of 3 plus 1, or the square root of 4, or 2. The reason why we chose the square root piece is because that 3 is included on the closed interval from 0 to 3. So part 1 of the definition of continuity checks out. The second part of the definition of continuity says that the limit as x approaches 3 must also exist. Since we have a break in our function at x equals 3, we need to see if the limit from the left is equal to the limit from the right. So we will investigate whether the limit as x approaches 3 from the left of f of x is equal to the limit as x approaches 3 from the right of f of x. On the left-hand side, it's just the square root of 3 plus 1, or 2. And on the right-hand side, as we approach from the right, it's 5 minus x, or 5 minus 3, which is also 2. So this checks out, tells us that the second part of the definition of continuity has also been met. The third part says that f of 3 must equal the limit as x approaches 3. And since we've just determined that the limit exists and is 2, and that the function exists at 3 and is also 2, we know that this is also true. So we can say that that checks out, and that the function is continuous at x equals 3. We've shown it using the definition of continuity. In this second question, we're going to take a look at limits as x approaches infinity and negative infinity. We have the function f of x equals 2x times e to the 2x. So to find the limit as x approaches infinity, all we have to do is think about what happens to this function as x gets very large. Well, 2x gets very large, and e to the 2x also gets very, very large. If you have a very large number times another very large number, we end up with another very large number. So the limit as x approaches infinity of f of x is infinity. For negative infinity, what we end up with is 2x, which is a very large negative number, and then an e to the negative 2 infinity. Since that is a negative exponent, it drops into the denominator and becomes e to a large number. And when we think about what happens, or how these increase, a large negative is increasing less quickly than e to a large number. An exponential always increases more rapidly than a polynomial function, and therefore this is approaching 0 as x approaches negative infinity. We weren't asked whether or not these were asymptotes or if it had horizontal asymptotes, but we could say that y equals 0 is a horizontal asymptote to the left, but there is no horizontal asymptote to the right.